Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up and it's a review of confidence intervals for the one sample T. So our scenario is a bolt diameter. So a hardware manufacturer produced a batch of 4,500 bolts used to assemble various machines. And suppose that the average diameter of a simple random sample of 50 bolts. So we have N is 50 because we have a sample of 50 has a sample mean of 5.11. So we have an X bar equal to 5.11 and a sample standard deviation of zero point 0.1. So our S is zero point 0.1, right? Construct a 99% confidence interval for the bolt diameter. So let's go ahead and write down the things that we know we have. We know our X bar is 5.11. Our sample standard deviation we know is 0.1 or just 0.1. Our N is 50. And the degrees of freedom are 50 minus 1 or just 49. All right, so our formula for the confidence interval is going to be X bar plus or minus T star standard deviation of the sample divided by the square root of n or the sample size. Well, the first thing we need to do is we need to go ahead and start calculating T star. All right. Well, T star is based on the fact that they want to create a 99% interval. Well, since they gave us a percent, we know we're going to be going to a inverse, but not a normal. This is a T. So we're going to go for an inverse T, and it's going to ask us for our area. All right. And our area is 0.99. So when I go into the calculator, I go second vars inverse t, but unlike the unlike the normal, I don't have left, right, or center, so I have to do some work. So instead of just writing 0.99, I need to do 1 minus 0.99, all in parentheses, divided by 2. And that's exactly what I'm going to type in the calculator. Parenthesis 1 minus 0.99, close parenthesis, divided by 2. And even though we're not quite there yet, well, we'll go ahead and do the degrees of freedom. And our degrees of freedom in this case were the 50 minus 1 or the 49. So I'm going to go ahead and write degrees of freedom is 49. Press enter, and we end up getting a T star of negative 2.6799. So T star equals negative 2.6799. And we're going to need that value to plug into here. I'm going to go ahead and take a moment and draw my confidence interval the way it's supposed to look. Well, this is pretty easy. We know that X bar is going to be in the center. In this case, our X bar happens to be 5.11. And we're going to be looking for a lower and an upper bound. And we know this area right here is 0.99. Well, the reason we had to do the 1 minus 0.99 divided by 2 is because that's what this area in the tail is. And if I go back to my calculator, I'm going to do this real quickly. Parenthesis 1 minus 0.99, close parenthesis, and then divide by 2. I find out I have 0.005. So I have 0.005 in this tail, and I also have 0.005 in this tail. Remember, this theoretically goes to negative infinity, and this theoretically goes to positive infinity. When I add up these three values, they will sum up to 1. Because remember, these two values together, the area in the tails is my alpha, and my alpha happens to be 0.01. All right? So I need to plug this into my formula. Well, we know X bar is 5.11 plus or minus. Our T star happens to be, we just calculated that. And by the way, we're positive people, and so we're going to just make it a positive. Life is better if we do. So our T star is 2.6799. Our sample standard deviation in this case was 0.1. And we're going to divide by the square root of 50. All right. Well, this is the work you needed to do just so that you can get your answer. But really, that doesn't get you any points on the AP exam. I need to name my inference procedure. Well, what are we dealing with? First off, how many samples? Well, we have one sample. What type of distribution? It's a t distribution. So one sample, t interval. And what are we working with? Means. One sample t interval for means. And that's where I need to go on the calculator. So second var's inverse, I mean, second var stat test, t interval, and I have stats highlighted. I'm going to plug in my x bar of 5.11, my standard deviation, which is 0.1, my sample size, which is 50. Now notice it asks for the sample size, not the degrees of freedom here. And then it asked for the confidence level, which they told us was 99%. So I needed to put in a 0.99, which is what we drew on our graph right there. When I do that and I press enter, I end up getting a lower bound of 5.0721 and an upper bound of 5.1479. So easy way to write the interval, 5.0721, comma, 5.1479. And I just copied that straight off the calculator. And I'm going to go ahead and label this as lower and upper. Not that I need to, but it's helpful. All right, we need to define the uh, the parameter. Well, we're doing something for means. We're trying to use the sample mean to estimate the true population mean. So let mu, we never estimate x bar. We know what x bar is. We're estimating the population mean. So let mu equal the true population mean what? Well, what do we care about? Bolt diameter. All right. And that's really all we had to say in regards to that in order to get full credit. Now we should on the AP exam, we're gonna have to give conditions. We didn't ask for it here in the warm up because of the time it takes to do. All right, our conclusion. Well, what are we? Well, we are how confident? 99% confident that the true population mean bolt diameter lies within the interval 5.0721 to 5.1479. Make that look more like a 4. 5.0721 to 5.1479. All right. The next thing is the meaning of the confidence level. And what that says is if we did this over and over again, how confident are we? So, in repeated sampling, we expect this method or our method to do what? Capture what? Well, the true population mean bolt diameter. How often? 99% of the time. In other words, 99% of the time, we're going to capture the true population bolt by a diameter. That also means 1% of the time, it won't. All right. I appreciate you watching and hope to see you on the next one. Thank you.